Right, continuing on, now going to Chapter 5, the first section we're going to look at is solving inequalities using addition and subtraction. Right, as we solve inequalities, we are going to have to graph them on a number line, so we need to discuss when to use an open and a closed out. So I got some examples here. Looking at example A, we got W is less than -4. So I'm just going to quickly sketch a number line. Since we're looking at -4, I'm just going to put a couple points, or label a couple of the intervals here. Well, -4, so we're going to go to -4, and it says W is less than -4. We don't want to include -4, it's not equal, it's less than. So since it doesn't include it, we're going to use an open dot. And anything less than -4, well, -5 is less than -4, so we're going to shade this way to include that. Looking at x greater than 10 and b here, so just getting this set up here. Well, at 10, we're going to put a point there, but we got a dot. We want to decide if it's open or closed. Well, it's x greater than 10. We do not want to include 10. 10 is not greater than 10. So we don't want to include it, so we're going to leave it open. And a number greater than 10 would be 11, so we want to shade the direction to include 11. In part C here, we've got m greater than or equal to 1. So we want to include 1 in this case because it's got the equal to piece of that. So we want to show that it's included, we want to use a closed dot. And then we want numbers greater than 1. Well, 2 is greater than 1, so we're going to shade to include that. D here, n is less than or equal to -4. Just getting this set up. Okay, well, we want to include -4, so we're going to use, since it's got the equal to symbol, we're going to use a closed dot. We want to shade to include numbers that are less than -4. Well, -5 is less than -4, so we are going to shade this direction to include it. So if you can see the main difference here, you're going to use a closed dot when you see this equal to symbol in there. If you don't see the equal to symbol, then you're going to use the open dot. Alright, so in this first example here, we've got the inequality m minus 3.8 is less than -1. We want to solve that and then graph the solution. This is very much almost the same thing as working to solve an equation. You look at the side of the variable, you want to get that by itself. So looking at the m, 3.8 is being subtracted, so we want to undo that. We want to do the opposite of that. So we're going to add 3.8 to the left. But what you do to one side, like an equation, you want to do to the other. So I'm going to add 3.8 to both sides. On the left, this here gives you 0, and you have -3.8, positive 3.8. So you're left with just m on the left. Inequality sign stays the same. And when you do -1 and 3.8, you get 2.8. So on the number line, we're going to go to 2.8. Since there's no equal to symbol in the inequality, we're going to use an open dot. So at 2.8, I'm going to put an open dot. I'm going to just kind of approximate this there, so it's there. And we want to shade numbers to include numbers that are less than 2.8. So 0 is less than 2.8, so I want to shade to include this here. Okay, so we're doing that. We should always check our answer. So if you look at the number line here, 0 shaded, and we can plug that in, for example, is 0 less than 2.8? Yes, that's true, so you know you've got the right one. Alright, here's the second and final example. We've got the inequality, solve b plus 7 greater than or equal to 10, and graph the solution. Again, it's very much like an equation. So we want to get the b by itself on the left side, so it's currently being added by 7, so we have to undo that. So we're going to subtract 7 on both sides. And after we do that, on the left we got b. On the right, we're going to have 10 minus 7, which is 3, and we're keeping the inequality the same. Since there's an equal to symbol in the inequality, we want to use a closed dot. We want to include 3. So we're going to go to 3, put a closed dot at 3. We want a shade to include numbers that are greater than 3, like 5. 5 is greater than 3. So we want a shade to make sure that we include those numbers that are greater than 3. And just test something, and look at your graph here. 6 is shaded, so plug it in real quick. Is 6 greater than or equal to 3? And yes, it is, so it checks out.